So now let's talk about the machine learning. So then let's discuss what is machine learning. So machine learning, the primary aim of machine learning is to allow the computers learn automatically without human intervention or assistance and adjust your actions accordingly in order to enable the better decision at scale. So machine learning model basically can use a supervised or unsupervised learning. A machine learning model can be deployed into an existing production environment. In machine learning, workflow can be automated by the likes of pipelines through the likes of DevOps. So if you see this, you have data and you have the output. So you have computer, when you give the data to the computer and you have the rules given across, you can predict the kind of output. This is the typical representations of machine learning. So you have data, you have computer logic, then you have the rules applied to the data, then you get an outcome which can be predicted. So now let's look into the example of machine learning versus the traditional programming. So the traditional programming basically differs significantly from machine learning. In the traditional programming, a programmer basically codes all the rules in consultation with the experts in the industry for which the software is being developed. So if you are doing a traditional programming, you have to write all the kind of conditions which has to be fulfilled. You need to look into aspects of each and every conditions. So your each rule is based on a logic foundation. So your machine will basically execute an output following the logical statements. So when the system grows more complex, more rules needs to be written. It can quickly become unsustainable to maintain. So if you are writing a traditional programming and if the kind of conditions are too many, it becomes practically impossible to maintain all the codes in a logical manner. So that's a typical drawback of a traditional programming. So you have your computer where you give the data and you put your rules on top of it, or rules or the programming conditions, and then you get a typical outcome. In the case of machine learning, so machine learning is supposed to basically outcome this issue. So in the case of machine learning, machine basically learns how the input and the output data are correlated, and it basically writes a rule. So your programmer do not need to write new rules each time when there is a new data. So your algorithms basically adapt in response to the new data and the experiences to improve the efficacy over a period of time. So in the case of machine learning, you have your data, you have your output. So your rules are basically defined by the machine learning algorithms based on the output which is supposed to be received. So your rules are basically all the logics and rules basically tweak based on the output which is supposed to be received by the machine learning algorithm. So the programmer do not need to write the new rules each time there is a new set of data. So now let's look at how the machine learning is related to artificial intelligence systems. So your machine learning ML is a subset of artificial intelligence. So if you see, the outer circle is called artificial intelligence, which talks about the ability to sense, reason, engage and learn. So you have in artificial intelligence computer vision, you have natural language processing, you have voice recognition, you have robotics or motion, you have planning and optimization, or you have knowledge capture. So that's the outer subset of artificial intelligence. So machine learning is a subset, or it's the inner subset of a outer set of artificial intelligence. So your machine learning basically comprises of ability to learn through the supervised learning, through the unsupervised learning, and through the likes of reinforcement learning. So that is a subset of artificial intelligence. Now, if you see the methods, that is again a subset of machine learning. So, methods basically talks about the ability to reason. So how you reason your data? So that is basically through the likes of algorithms, and these are your regression, decision tree, classification. So these are few of the methods by which you do the reasoning. So that is called the ability to reason. And then inside it you have various technologies, and these technologies are called the physical enablements, and these are the kind of platforms, the APIs, the sensors, and so on and so forth. So that's how you have artificial intelligence as a superset, machine learning as a subset, and then methods are again a subset of machine learning, and the technologies which are being used across. So this is how you can associate your machine learning with the artificial intelligence system. The idea of training and learning from data. So in the case of machine learning, there are three important concepts. First is data, second is algorithm, the third is the model. So now let's look into each of these in detail. So definition. So model training. Model training in machine learning is the process of feeding a machine learning algorithm. So we are saying we are feeding a machine learning algorithm with the data to help identify and learn good values of all the attributes which are involved in it. There are several types of machine learning models, of which the most common ones are supervised and unsupervised learning. So you have the algorithm, which is your machine learning algorithm. You feed the data to this algorithm, and then once you feed the data to the algorithm, you basically look for the various attributes which are involved in it. So you have various learning models. So FX is basically denoting your various learning models which are there, and these learning models can be classified as a supervised learning models or unsupervised learning model. So now let's define each of these entity. So algorithm basically in machine learning is a procedure that is run on a data to create a machine learning model. For example, fx is equal to ax plus b, which is a general formula for a linear regression. So algorithm, if you see, this is a procedure which you run on the data to create a machine learning model. So if you have to create a machine learning model in form of a linear regression, your algorithm is, in this case, is a linear regression. Now let's look at the data. So machine learning algorithm basically builds a model based on the sample data, which is known as the training data. So whatsoever data you are feeding it to your algorithm, that set of data is called your training data. So that training data, in order to make the predictions or decisions without being explicitly programmed to do so. So you give the training data to your algorithm, and you are not programming your algorithm for each and every condition. You are just ensuring the data is fed, and your algorithms is basically taking decisions or actions based on the data being received. So you are basically allowing your model to learn based on the data and algorithm which is fed across to it. So now let's look at a model. So model in a machine learning is the output of machine learning algorithm. So you have machine learning algorithm, which is, as I said, is a kind of linear regression program. As an example, you can have linear regression, you can have bivariate regression, you can have classification, you can have multiple other. So these are the various algorithms which can be used in your machine learning. So when you have your data interacting with your algorithms, the outcome or the output of machine learning algorithm basically runs on that data. So model is basically the output of your machine learning algorithms which runs on the data. So in this example, if you say your algorithm was fx is equal to ax plus b, your model is basically your fx is equal to 3x plus 2. So this is your model. So hence, your algorithm can be a linear regression, it can be bivariant regression, it can be a classification algorithm. There can be multiple types of algorithm, but then model is derived as a output of your machine learning algorithms when data runs on that algorithm. Yeah. So now let's assume that 99% of the time people would be using out of the box algorithms that are free to use available for them. So these algorithms, as I said, right, they would be typically readily available algorithms given across in the market. So what you do is you basically train, use the training data. You basically pass those data through the algorithms, and then you create your models. The model which is created, that is the most important aspects of your machine learning. So your machine learning, the most important thing is model, and these model basically modify themselves based on the training data and algorithm which is fed across to them. So the algorithms which are available, they they are they are basically out of the box algorithm, and they are easily available in the market.